There are times when if you use the tool on the gCADPlus drop-down menu to insert a Google Maps stroke image into a gCADPlus drawing, you don't quite get the result you're after. If you look, perhaps you won't be able to see it, I imagine, but down at the bottom of this image here, which I'm about to put into the gCADPlus environment, I can't see the scale very easily. Let's cancel from there, and let's just move up a little. So when I cut and paste it and look down the bottom here, I don't get this scale, although here it is here. So if I change my background colour, I think I can read, well, I'm not sure what I can read there, 50 I think, and that's with some degree of difficulty. So if I have a measurement from ground truthing, I've been to the site, and if I can measure something, I'll be able to scale the image, provided I know, say, the width of the road or width of one of the length and breadth of one of the buildings. I would be able to scale the drawing. So in not every instance does this option, insert Google Maps image into a drawing, work brilliantly. There are times when it's better to use Google Earth. So let's have a look at this same site using Google Earth. Well, here we are in the Google Earth environment, and I think we've got a nicer image, but more importantly, we've got the scale bar at the bottom of the image, so we can save this image and use this button up here in Google Earth, save the image, and we'll pop it in here, and we'll call it, we'll just call it image 101 for the moment, and we'll save it. And now we can return to gCADPlus and see if we can paste that image in. So here we are, back in the gCADPlus environment, raster image. I'll delete that one there and add a new one, image 101, and insert it, and OK. So in goes the image now. We can begin adding information to it. We can draw on top of the site. As a landscaper, you might be interested in making some lines and other information above these grassed areas through here, and we'll do that in a moment. But the important thing is we have a scale bar. If we measure using our measure tool, which is up here, if we measure from one side of that scale bar to another, we should have 102 meters, and we've got 4316 units. So we have to convert this and make it a full-size drawing. So I'll go about doing that. That's just a matter of doing the calculation and then scaling the image. I'll call up the inbuilt calculator in gCADPlus, and our scale bar said 102, and we were reading 4317. So we've got to scale the drawing down by 102 divided by 4317, 4317, and that equals 0.02362. Will be accurate enough for our purposes. So to scale the image, we select it and left click and select scale. As a base point, I would use 0, 0, but you could pick anywhere in the image, and the scale factor is 0.02362, and hit enter. Right click, unselect all, and zoom extents again. But what we're interested in now is seeing if, after scaling the image, do we get numbers that mean something to us in the real world if we went out on site. So let's measure from one end of the scale bar to the other, and we get 102. Now, so I can work on this drawing now in meters as my base unit. If you're in the metric environment, you might well want to work in millimeters as your base unit, but it depends on the size of the project. Units in gCADPlus are arbitrary. We just measure numbers as we measure our distance, and the conversion is done in a sense in our head. So we know that this drawing, we're thinking now in metres. So if we wanted to measure the width of that access road, it would be from one side of the access road to the other, it's 8.5 metres wide. But since this is the US example, what we now want to do is convert metres into feet. Well, 1 metre is equivalent to 3.28 feet, so that if we select this right-click scale again from 0, 0, and we scale it up by 3.28, and we zoom extents again, we've now got a drawing that should report back to us. Remember, we measured that driveway as 8.5 metres, so let's measure it again from one side to the other, and we get 28.29 feet. So at this point we ignore that scale. We've done our own scaling in this drawing, but it's full size in terms of feet. You might want to get in and edit the image file and just eliminate that, or even draw a rectangle, 2-point rectangle. I've been trying to mask that by giving that a fill, and now we've masked that. So, and we could put some text in there. In fact, we could have copied that bar or put our own scale factor in. But we know, as we're working on this site, that our measurements are in decimal feet. What I'd now like to do is to create a couple of layers. So I'll make a new layer called image, and just select the image, and by using the properties box move that to layer 1. It didn't bite, did it? I forgot to hit the enter key. So we're going to call this one image. You must hit the enter key at that point to bite it in. So now it's on a layer, and well, we might want to create a new layer called grass for the sake of argument. And we might even, for the moment, change the colour of the grass layer to something that is easily seen. So we could jump in here now and start drawing some polylines for, say, areas of grass. So let's imagine that you as a contractor were responsible for mowing this area through there, so you could draw a polyline over it. We might start there, although I'd imagine the boundary of this probably goes to there and then runs through here. So let's imagine that we're not too certain of it, but what we want to do is just get some rough estimate of the size of that area, and we'll close it. Now when we pick it, we get the area of that in square feet, so it's 16215 square feet squared, in other words, is the total area of that, and that area could be hatched. We could draw a similar, and by the way, I want to move that away from layer 0 onto the grass area. That could be grass zone number 1, this could be grass zone number 2, and we could mark out our car parking area. You can see a vehicle and trailer has been moved in on that area. We could then draw the footprint of the house, and it's a good idea to put these, as you're drawing on top of the image, it's a good idea to put those on separate layers. Let's just check, using our distance, the length of the average vehicle, 15.8 feet in an average US vehicle, and I think that's reasonable. We could probably find somewhere the dimensions of a standard car parking area in the US, just to confirm that we've got things scaled correctly. So can you see we're now using a base map, an image of the site, and we're building our own information on it. Well, here I've taken the design just a little further. I've added a scale bar. Let's pan up a little and pick the horizontal line in the scale bar, and you can see that's 50 units or 50 feet. So we could use that scale bar as an internal guide. I've hatched the area or a number of different areas of grass. What I wanted to show was that if you pick the polyline that encloses the hatched area, it's easy to change the polyline and move it, and you'll see that the hatching follows it. That sort of hatch an entity such as a polyline gives you a great deal of flexibility when it comes to subsequent editing. We can just move things around. It's also possible to insert a vertex, so I can add another vertex there for finer control if I want. And I might want another vertex here, and that will enable me to square off that area through there. So I'm sure you get the drift. Let's move now into a layout space, and if I right click on there, Layouts Manager, you can see that's set to US letter size in landscape format. I'll right click and zoom extend. So there's our final map, and we can print PDF or print whatever we like from layout space. And I think we've achieved our aim.